For this video, you will need the provided note sheet, notebook paper, and you might also want to have highlighters. So if you want to pause the video to get the supplies you need. In this video, you will learn how to graph quadratic functions in standard form. So let's first look at a graph of a quadratic. The name of that graph is called a parabola. This line that goes down the center of the parabola is called an axis of symmetry. It is a line that cuts the parabola symmetrically, or you can think about it as cutting it into two mirrored pieces. Another part of the graph that we want to be familiar with is here at the very bottom, or sometimes at the top. It's called the vertex. This point is where it's going to change from curving up to down, again depending on if that vertex is at the top or at the bottom. So this is where you might, before we do that, the vertex is always an XY ordered pair. So this is where you might want to highlight that a vertex is this point and the axis of symmetry is this line. So for this graph that we are looking at, the axis of symmetry is at x equals 1 and the vertex is at the ordered pair 1, -4. Notice the x value of the vertex is the same as your axis of symmetry, and that will always be true. So let's look at some more information about a vertex. So the vertex will be a maximum or minimum point depending on if it opens up or opens down for the graph. In order to open up, we have the vertex at the lowest point. So that means it will have a minimum value. So if it's opening down, the vertex is the highest point. So that means we have a maximum value. A quadratic function, by the way, the standard form, so let's fill that in this box. The standard form is ax squared plus bx plus c. A quadratic function, when you look at the a value, it can determine if your graph is going to open up or down. So let's go ahead and jot down that. So if a is a positive number, then that means your graph is going to open up and point towards the positive. So think about if a is positive, it's a point towards the positive. So here's our vertex. It's the lowest point, so it will be a minimum. So that means if a is a negative number, our graph will open down, again pointing towards the negative. Here is our vertex, it's the highest point, so it means it will have a maximum. We'll work with this more when we get into our examples. For our axis of symmetry, if we're given a graph, a lot of times it's easy to identify that axis of symmetry. However, sometimes we'll just be given a function. So the axis of symmetry formula that we will use will be -b over 2a. I highly recommend you putting the 1 there. I find that students do better with their work with -1b over 2a. Notice on your note sheets there's several boxes of information. We are going to do these steps in our example, but they're always good to refer back to if you're not sure how to follow your notes. You can always come back and follow these steps to see what we are doing. It describes each of the different things that we're going to learn in this lesson. So let's go ahead and go to notebook paper for our examples. So first of all, let's remember what standard form is. A quadratic quadratic functions, we should see y equals ax squared plus bx plus c. So these are the type of equations we're going to be working with today. So for example number 1, we have y plus 4x minus 2 equals negative x squared minus 7. Well, right off, this does not look like that standard form. So we might have to do some work with that. So all we will have to do is solve for y. We're going to have to put the equation in standard form by solving for y. You can get y by itself. So let's see what that work will look like. Here we have our variable y, and these terms we need to move away. In order to move the 4x term, we're going to subtract it. And over here on the other side, there's no other x term, so we're just going to tack it on to the end for now, and then we'll worry about getting it in the correct form later in our steps. But by subtracting that 4x, it does cancel it away from this left-hand side. The same with our negative 2. We need to add 2. It does have a like term, so we'll line it up with that negative 7. So again, it does cancel out, leaving our y by itself, which is what we need. Now we'll need to simplify and write this in the correct form, putting our ax squared term first, so this negative x squared. Then we'll want our bx, so that's where we're going to grab this negative 4x. And then finally our c, so negative 7 plus 2 gives us negative 5. Once you have your equation in standard form, we're going to want to name our a, b, and c. Notice the a, b, and c can be found when it's in the correct form. So here a equals negative 1. It's just the number in front of x squared. B is negative 4, again the number in front of x. And c is just the constant that's at the end. Always being careful of your signs. And then also notice I never included x or x squared when naming my a, b, and c. Once we've named our variables, a, b, and c, we're going to use the axis of symmetry formula. So that axis of symmetry formula is x equals negative b over 2a. Again, remember, I find that students do best by doing negative 1b over 2a so that you can correctly calculate that axis of symmetry. So let's plug in our numbers. So negative b, plugging that in, over 2a and plugging that in as well. And then work it out. A negative times negative is a positive. 2 times negative 1 is a negative 2. And then we divide to get our axis of symmetry to equal negative 2. Once you have that axis of symmetry number, we're going to plug it in to find the y value. Our goal here is to find the vertex, the xy ordered pair. So we now have our x. We're going to plug in the x, plug in the x value to find the y value. So take this x value back into the equation that's in standard form and solve for y. So y equals negative, and you might want to put negative 1. Negative 2 is going to be squared minus 4 times negative 2 minus 5. Notice that when I'm squaring a negative, I have to put in parentheses. I really recommend anytime you're plugging in a number to use parentheses so that when it's required, you don't mess up and forget to have those parentheses around that negative number. So once you set that up, grab your calculator, or of course you can just work it out using order of operations. But in your calculator, you will type exactly what you have written. So negative 2 squared minus 4 times negative 2 minus 5. Being very careful that exactly what you have is what you type in. So that value equals negative 1. So once we have that value, we're going to write our vertex. Our vertex is an x, y ordered pair. So we just found here the x value. This is now the y value. So we plug that in our xy ordered pair for our vertex. -2, -1. So to finish this problem, we want to talk about this vertex and determine if it is a maximum or minimum. So let's talk about max and min. If A is positive, that means our graph is going to open up, pointing to the positive. So there's our vertex. It's going to be the lowest point, a minimum. If A is negative, our graph is out, open down, pointing towards those negatives. Here's our vertex. It's our highest point, so that means we have a maximum. So go back and look at your A value from where you named your A, B, and C. Here we find that our A is negative, so that means our graph's going to be opening down, and we have a maximum. That vertex is the highest point on the graph, and the maximum value will be the same as your Y number. So the value for maximum min will equal your Y. Let's take a look at example number 2. This problem we're going to have y equals x squared plus 4x. Again, let's write it in standard form. If you need to, rewrite it so you see your ax squared, your bx, and your c. In this case, c is 0. So if you need to tack on a plus 0 at the end, feel free to do so you can name your a, b, and c correctly. That is our next step. For a is 1, b is 4, and c is 0. Use those in the axis of symmetry formula. Negative b over 2a, plugging those in. So we have negative 1 times 4 over 2 times 1. Negative 1 times 4 is negative 4. 2 times 1 is 2. And then we divide, we get a negative 2, and that's our axis of symmetry number. We want to find our y value so we can write our vertex. So go back and write your equation with plugging in your x. So negative 2 squared, again being very careful that we use parentheses around those negatives, especially when we're squaring them, plus 4 times negative 2. So at this step, if you want to use order of operations to solve, or just let your calculator help by typing it in. So we have negative 2 squared plus 4 times negative 2. When we work that out, we get a value of negative 4 for our y value. So to write our vertex, it's an x, y ordered pair. So our x number was negative 2, our y number is negative 4. To talk about max or min, look at your a value. If a is positive, that means that the graph will open up. The vertex is the lowest point on the graph, so it means we have a minimum. That minimum value will be the same as your y number, so a minimum at negative 4. That means when we were to graph this problem, the lowest it will reach on the graph is negative 4. Let's take a look at our next example. So for number 3, here we're going to have y equals negative 3x squared plus 7. Again, we need to make sure we're noticing these functions in standard form. So if you need to rewrite it, y equals negative 3x squared. That is your ax squared term. Notice this time 7 is not our b. It doesn't have the variable x with it. So really what we can put in here is plus 0x, and then that 7 is our c. So if you need to add that to notice that your b equals 0, feel free to do that. Here a is negative 3, b is 0, and c is 7. So let's start with our axis of symmetry formula, negative b over 2a, and carefully plug in our numbers. So negative 1 times 0 over 2 times negative 3, and work that out. Be very careful when you're plugging in your numbers. Some people want to put a in the top and b in the bottom, and that's not how our formula says to set it up. Be very careful that you're plugging them in the correct places. So negative 1 times 0 is 0, 2 times negative 3 is negative 6, and of course when we divide 0 by any number, it does equal 0. Just a kind of tip to notice, anytime your b is 0, your axis of symmetry will be 0. So let's find our y value for our vertex. Going back to our equation in standard form, plug in your x that you just solved for. So again, you can use order of operations to solve, or go to your calculator and type in exactly what you have. So negative 3 times 0 squared plus 7, and that's all worked out, it equals 7. So for our vertex, we will have an xy ordered pair, 0, 7. Go back and look at your a value. Because that a value is negative, our graph will be opening down, pointing to those negatives. That would leave our vertex here as a maximum, and that maximum value is 7. That's as high as this graph will reach, is 7. Let's take a look at one more example before we actually start graphing these. Example number 4, we have 5x plus y plus 6 equals 2x squared plus 5x. So we already know we need to get this in standard form by solving for y. So let's first move or subtract 5x from both sides. It does cancel from this left-hand side. And we also need to move or subtract the 6 from both sides. Notice the 6 does not have a like term, so I'm just tacking it on at the end for now. So let's write it in the correct order. We have y equals the 2x squared will be our ax squared. Our b terms, notice what happens here. 5x minus 5x, they cancel one another. So you could write 0x so that you'll remember your b is 0, or if you just want to move on and write your minus 6. This is the simplified form of the equation, so when we name our a, b, and c, a equals 2, b equals 0, remember because those canceled out, and our c is negative 6. So let's use those in our axis of symmetry formula. X equals negative b over 2a, plugging in your numbers again very carefully. So negative b over 2a, all of this does work out to be 0 over 4, which is just a 0. So again, we see that when our b equals 0, our axis of symmetry equals 0. Let's take and find our y value. We have 2 times 0 squared minus 6. If we work that out, either with order of operations or typing each thing in our calculator very carefully, we find when that's all solved, it equals negative 6. So our vertex for this function would be 0 was our x, comma, negative 6. Go back and look at your a value. That a is positive, so it's going to open up, pointing to those positives. That means our vertex is going to be the lowest point. It's going to be a minimum. The minimum value will be negative 6, the same as your y number.